Welcome back to the hyperbolic coding chamber. It is day 100 and question mark. We're uncertain, but what we do know is that there's another day and another dollop of suffering. So that, okay, we're way off. It's actually day 166, but nonetheless, we're going to continue anyway. There was something interesting that I was reading. Those in Discord already got the heads up. It was about stylometry, and this guy pretty much made a tool where it could take a body of your writing, right? Like, just a bunch of your writing on Hacker News, a bunch of comments that people wrote. And basically, it would figure out what your alt accounts were. So these were other accounts that people write on. They have different accounts, or they want to say something that other people might not like. And so it's very interesting because it's like the way your style of writing, I was actually able to relatively accurately point you to your other account, to tie you to another account. And it's just this very interesting concept because another interesting thing is that there are other people that you're tied to. So it's interesting because it's like just based on, the algorithm was very, very simple, but you'd also have other people who, may not be your alt account, but also type or talk similarly to you. So it's just very, very interesting. It's very, very interesting. I wonder what the applications of something like this could be. Would it be interesting for you to be put in a chat room with one of your style doppelgangers? Would you have a good conversation with this person? Is style an encoding of more than just word choice? Could it also be interest? Could it also be political affiliation, ideation, experience? It's hard to know, but what's interesting is that the method they use is very, very simple. It's just based on your frequency of word usage. So it's just so interesting. I really wonder what the other use cases could be. I really would be interested in an app that would take like a corpus or a huge body of your writing and just put you in a chat room with the other person. And maybe that would be the wave. Maybe that would be the way people find new friends in this world. Maybe you could link your Discord account based on all the Discord messages you've sent. You'll be matched with someone who speaks just like you, and it'd just be really interesting. But also, based on the style, you could also match people with people who are the complete opposite of you as well. But just interesting because the method that's being used is very rudimentary and it's already effective. So if we layered on some language models and time of day and all these other things, like it'd just be so interesting. I'm relatively certain there's a movie about this where there's an app that comes out that makes it like matches you with your soulmate or something like that, and then people just start like leaving their partners and instantly divorcing and stuff like that. But it's just so interesting. Is this post the beginning of that movie? Is that movie made by a time traveler from the future who came back to the past today to make it, to warn us? So that is the real question. My answer is yes. So maybe I'll post the link to the Hacker News stylometry thing in the description. But yeah, it was pretty cool. So I'd be interested to see some applications of it, like maybe a new form of dating app, maybe a new form of a friend finder would be kind of cool. Because that is just very interesting. So that's all we have today. But we also have more of YouTube comments. So we have a comment from Zemeli Bella with a W profile picture. You can tell this is a W human. And happy Leetsgiving. I'm a Python developer. You should try a graph theory question for entity resolution. Okay, Zemeli is a problem. Okay, so Sensei, very hard and actually a real world problem. The best solution is using probabilistic data linkage methods. Could go as far as complicated ML2. May not be necessary since some packages exist. Interesting. And you should try. You are the cheat code. Please guide me, Sensei. Yeah, there's a lot of things that I don't understand in this comment. So, for example, entity resolution. My background is making me think it's hard for me to unlink entity resolution from game dev. So that's what I'm thinking, but we definitely dipped our toes in some graph theory, but still super noobage on it. So we know there's a couple algorithms, but we have a lot of work to do to catch up. and then it may not be necessary since some packages exist. I wonder if this is some sort. If this is, I'm sure questions like this exist. Maybe on, there's not LeetCode, but another way. Oh, Kaggle. So I think Kaggle has like kind of like a version of not really LeetCode, but problems you can do. That it feels like I could probably do this on there, but that's pretty interesting. And then we have Yasir Gauti. Yo, bro, it's been a while since I watched your last video. Whatever, I'm back to your inspiring videos. Anyways, that was the segue. Quick question though. I just finished learning strings and arrays and C language. Gee, the man has mastered C. So I tried to solve some LeetCode problems. I solved some of them on Visual Studio, but I couldn't deal with their IDE. I don't know why he's working with only pointers or just C is hard on it. So some of them on Visual Studio, but couldn't deal with their IDE. I don't know why he's working with only pointers or just C is hard on it. I haven't used a lot of C, or Visual Studio, but I know Studio is a beast of a program. That program is actually massive. Like, it is actually a massive program. And I actually, every time I've had to use it or to compile like a large project, I just couldn't get it to work. So you might be running into that. It might just be easier to use something like VS Code, not for a full project. Cause there's a lot of important stuff you get with the IDE, like IntelliSense and all that stuff that you probably need, but especially with the package linking and all the compiling and stuff. But if you're just doing some LeetCode problems, you could probably just pop it into Visual Studio Code and just like run a C compiler in the command line or something like that. Might be simpler than using Visual Studio. But also, I'm not sure exactly what the setup is or exactly how the question is being phrased. So it is hard to know. But I definitely know that C and C++ take a little bit to get going. So I believe in you. But I believe. That being said, what I don't believe in is my ability to continue doing LeetCode. But the way that we have continued is by the grace of the members of the Hyperbolic Coding Chamber. So if you didn't join the Discord, last night we had Adam Sandler come through with Elon and Drake, and they gave a legendary motivational speech on graph theory and entity resolution. So if you're feeling like you need a little bit more of a refresher on those topics from an unorthodox host, you should definitely join the Hyperbolic Coding Chamber Discord. Next week we're going to have, I think we have Taylor Swift scheduled for just a refresher on Dijkstra's and Prim's algorithm as well as some MST stuff. So definitely going to want to show up for that. And yeah, there's not much left to do but to return to LeetCode. So we're going to do a nice little hour session. I was rushing through this problem, but I think we can solve it. I think I just ran out of brain sauce. We're given an integer array score of size n, where score sub I is the score of the ith athlete in a competition. All the scores are guaranteed to be unique. Athletes are placed based on their scores, where the first place athlete has the highest score, second place athlete has the second highest score, and so on. The placement of each athlete determines their rank. The first place athlete's rank is gold medal, second place athlete's rank is silver medal, third place athlete's rank is bronze. For the fourth place to the nth place athlete, their rank is their placement number. Xth place athlete's rank is X. Return an answer of size n, where answer sub I is the rank of the ith athlete. So what they don't tell us is that this array is the array of scores, and we're actually not supposed to change the order. So what we should do is have first, second, third here, and then this should actually be fourth place and fifth place since they have the lowest scores. And so this one should be first, second, third, and then we should have 4 and 5. Right. So what we're doing here in our current version is we take the scores array, we map it to create a place just confusing. We should just say that this is a value. We take the value and its index location, and we map it to its value and its index location, and then we sort them all in descending order based on their value. All the scores are unique, so we could also just do a map as well. And this would be n log n. I'm trying to figure out why I used index I here. To preserve their location. Post sort. Then I map it to I2 string. Yeah, this wouldn't work because this presumes that I is the original order they should be in. Yeah, something is confusing about this one, but I think what we're doing doesn't make any sense at all. Since the values are unique, we could just make a map of the value to the actual place that it should be. If that's the case, then we could actually keep the sorting, but we'll remove the mapping part. Yeah, we create a map of scores to place. Once we have the map of scores to place, we can just iterate over the array of scores and replace it with their place. But no, you'd also need their place in the index as well. You create a map of a tuple for the index that it's originally at and its place. Why is this, something is so confusing about this problem? I think it's because I'm not exactly certain. Something is very confusing, but we can create a map of score to a tuple of the index and the value or their score. Now we're actually mapping it to their score, so it doesn't make sense that their index I think I figured out why it's so confusing. The third missing piece of the problem, or the data that's sort of hidden, is that the index, the score index, is the athlete index. So what we should do is create a map of score to the place you get for that score, as well as the athlete index who should receive the place for that score. But now to get the places, so your athlete index and your score. What is going on? Why is this so confusing? It looks like we're losing the space, the mapping of these particular indexes. This is gonna map the score to the place. But then, iterating through score, and I say, okay, well, what's the place for the score of 5? And there's no score of. Oh, I used. Might be some overshot. 6, 5, 4, 3, 2. Oh, unless this is index and this is actually points. Wait, my sort isn't even working. Oh, I forgot I removed. Okay. I think I see what's happening. That was a miserable problem. I'm not exactly certain what is so confusing about it. For some reason, even after solving it, it's just hard to. Something about this problem is very strange. I'm not exactly. I don't even know how to put it into. Oh yeah, I was gonna say we could do this with a heap, but. Has something to do with heaps. How would you have done this with a heap anyway? Even if you load them in, you can get. Even if you load them in, you can get. Even if you load them in, you can get the values out in the order you want. I'm not saying how that helps. It could help. It could prevent us from having to sort, which you could probably get this to linear time with. Because if we can get the values out that we need immediately, then we can instantly create a map of the place to the of the score to the place. And you wouldn't have to sort like I did here. The heap part would, I think, would remove the sorting required. Seems good enough, so we'll keep moving. So here we have, oh man, this one has major downvotes. Let's add detect capital longest uncommon subsequence and minimum absolute difference. Given two strings A and B, this one has 5.9 thousand dislikes. Given two strings A and B, return the length. Return the length of the longest uncommon subsequence between A and B. Given two strings A and B, return the length of the longest uncommon subsequence between A and B. If the longest uncommon subsequence, how do we know if it's uncommon? How many times it appears? An uncommon subsequence between two strings is a string that is a subsequence of one, but not the other. A subsequence of a string S is a string that can be obtained after deleting any number of characters from S. For example, ABC is a subsequence of AEBDC because you can delete the underlying characters to get ABC. Other subsequence of AEBDC include okay. Given two strings A and B, return the length of the longest uncommon subsequence between A and B. If the longest uncommon subsequence does not exist, return -1. An uncommon subsequence between two strings is a string that is a subsequence of one but not the other. Subsequence of one but not the other. uncommon subsequence between two strings is a string that is subsequence of one but not the other. I guess the first thing we would need to know is how do we know if a string is a subsequence of another string? I was thinking of a way where we could do a two-pointer approach where we're looking for the longest I think they're making this sound more complicated than it is. I think we're looking for the longest non-existent subsequence, because uncommon is just a really weird way to say, because they're saying ABC is a subsequence of AEBDC, because you can delete the underlying characters in AEBDC to get ABC. But if you go to the example, one longest uncommon sequence is ABBA, because ABBA is a subsequence of ABBA, not of CDC. And these are also bad examples because the lengths are all the same. If the lengths are the same, and the strings are different, you always return the length of the string. So I think if we return this, we should pass the first three cases. Oh, right. Otherwise, return -1. Right, so you can pass these three cases, but it kind of hides the complexity because the real issue is when the strings are of different lengths. I'm thinking of a two-pointer method here. Thinking of a two-pointer method. And we should add a test case that actually tests something difficult. Have A, B, C, D, E. The answer here should be 5. Output is, oh yeah, they don't share a subsequence. So we should make this A, B, C, D, E, F, F. Wait, it's non-existent. either I'm thinking this goes two ways. Either this problem is overwhelmingly complicated and it's actually a medium, or it's actually a really simple solution. The part that's confusing is the uncommon subsequence. Basically the longest non-existent subsequence. Let me try a slightly different test case. We'll do A, B, C, D, E. If we do something like this, the longest non-existent subsequence should be 1. Are they the same? Yeah, if they're the same length, I forgot. And the answer is always... The answer here should be 2. Yeah, but expected 6. How is the answer 6? The longest non-existent subsequence. Interesting. Looks like we just needed to spend some time figuring this one out. And I knew it was some nonsense like this. The way it was worded was very confusing. And I was like, oh, this is probably really simple or really difficult. We went with the simple route. And it looks like there were some simple rules that we could expand throughout. So this seems like constant time, basically. Or actually, no. I guess it's linear time in the worst case, because we always have to check if A equals B, which is going to be the max of A or B operate. I know it's going to be, yeah, if they're the same length, then we check it. So I would say, yeah, it's going to be linear time in the worst case, where n is the number of characters in the string A, which would be the same number of characters in the string B with constant space. I wonder what people had to say. Given the root of a binary search tree, return the minimum absolute difference. The minimum absolute difference between the values of any two different nodes in the tree. The minimum absolute difference. So it looks like our values can be negative. No, it can't be negative. So the minimum absolute difference would just be the two smallest values subtracted. Another question would be, is every node in the tree unique? I think the place where we'd find the best difference, since it's a BST, would be in the left or the right nodes, because the left nodes, the value should be less than or equal. So I think we should just have to keep track of that value and check the whole tree. And I think we should be fine. So we check 4 minus 2, we'd get 2. We check 4 minus 6, the absolute value would give you 2. We check 2 minus 1, we get 1. We check 2 minus 3, we'd also get 1. So we'd return 1. Here we check 1, we'd get 36 and 1, so we'd return 1. I think we could do this in linear time. So I guess we'll use an object so that we can access the most up. So we're going to be using DFS to access, pretty much traverse the whole tree, but we want to have access at every level in the DFS tree. We want to have immediate access to the minimum difference variable. And one way to do that is for us to access it by reference. And so to do that, we have to wrap it in an object. So we can return o.minDiff. This function traverse will take a node, which will be a tree node, or null, as well as the o object, which just has minDiff as a number. And then here we'll just do like regular. We'll say o.minDiff is equal to the math.min of node.val. Do like this, with that absolute value of node.val, right, minus the left child. Left child might not exist though, so what we can do is do node.left or 0. And then we can duplicate the same thing for node dot val minus node dot right dot val coalescing to 0. And we're missing something here. Expected 1 argument, got 2. Node dot math dot ab. Oh, I think we need to close this. And then we can do traverse node dot left. I think this should work. Forgot to use nullish coalescing. I mean, safe navigation. Well, we don't have to do node. We don't have to safe navigate on node because node exists. But we don't know if node. Oh no, we have to do node. Yeah, so we actually do have to do it here. No, I don't think we need to do it on. Oh, and we also have to add our third value, which would be o.mindiff itself. And I'm just realized we can't start it at 0 because that would always give us the minimum value. So we'll start it at infinity. And what we'll do is if the right value doesn't exist, we'll change this to infinity so that we don't get the incorrect values. Oh, wait, no, this only checks the local differences. Oh, that was a noob mistake. Minimum absolute difference. Between any 2 different nodes in the tree. Well, I guess if we could just simplify this whole thing and just turn the whole thing into an array of values that we then sort and return the difference between the 2 smallest values. So from there we could do r.sort a b a minus b. Then we could return math dot absolute value of r sub 0 minus r sub 1. And then we just have to pass traverse in here with root and r. Just going to start as an empty array of numbers, and we actually won't return anything. Minimum difference. Wouldn't the minimum difference be between the two smallest values? So if we print our output is 61, which is what you get when you subtract 445 and 34, but they said minimum difference. And actually, it's between any two nodes. I keep forgetting that. Any two nodes. That's the case. There's no point in sorting. And we'll just return lowest diff. And from here, we'll just do a double for loop. Or end up with n squared time. We'll say 1. We don't want to consider the same indexes. We'll say lowest diff equals math.min lowest diff and r sub and the math.absolute value of r sub I minus r sub m. Our output is 0. Now, why would it be 0? There's nothing you can subtract by itself here that would give you 0. So I does not equal m. That's my bad. I think I definitely overcomplicated this one, to be fair. Or I didn't think about it enough because I kept doing stuff that was like way too simple. And it said any two different nodes. It seems like a lot of BST problems can be broken down into just shoving it into an array and then doing something on it. But I wonder if there's a better way. Is there a better way to get the difference in n squared time? So we're doing n squared time with linear space on the stack for the traversal, as well as the array. Well, let's think of the minimum difference would be, I thought, between the two smallest elements, but it could also exist somewhere else in other elements too. It's hard to think of a way that doesn't check every node against every other node. Maybe you wouldn't have to do that. If you sorted it, you don't have to do n squared time actually, because the best difference would be between a node behind you and the node in front of you. So we could shorten it that way. Then we could do you could say math.min of lowest diff of math.abs of r sub I minus r sub I minus 1, as well as math.abs of r sub I minus r sub I plus 1. And we'll start it with the math. We'll start it with, we'll start default value with r sub 0 minus r sub 1, because we know that we have at least 2 nodes to start with. Oh, that's pretty cool. So this way we can get n log n time. So I wonder if there's a linear time solution. Ah, I see. We actually don't have to sort, because if you do in order, oh man, I always forget in order traversal of a BST gives you an array already sorted. So it could be done in linear time. Or it do be like that. So also got to keep that in mind. So that is good enough, and we'll stop there.